Multiply the following rational expressions. State all non-permissible values. In order to multiply rational expressions, first, if the expressions are not already in factored form, factor all of the expressions on the numerators and denominators. To do this, we could use the greatest common factor method. We might use trinomial factoring if we have trinomials, or if we have binomials that are difference of squares. We then multiply the numerators by each other and the denominators by each other. This is just like when multiplying fractions. Keep it, however, in factored form. Do not distribute or use FOIL. As an example, for x minus 1 over x plus 2 times x plus 2 over x plus 3, note here they are already in factored form. Multiplying gives x minus 1 times x plus 2 over x plus 2 times x plus 3. Then cancel out the factors that are common to the numerator and denominator. This is the same thing we did previously with simplifying rational expressions. In this case, we have an x plus 2 on the numerator and denominator to cancel out. We then get the result, x minus 1 over x plus 3. Note that the cancellation can also be done before the multiplying. This is called cross cancellation and is similar to what we can also do for fractions. So before multiplying, we can cross cancel the x plus 2. The non-permissible values are values for which the variable for the expression to be undefined. Always apply this before any cancellation of factors. Simply look for values that make the denominator equal to 0. For our example, the non-permissible values are x cannot equal negative 3 and negative 2. This corresponds to the x plus 2 being equal to 0 and the x plus 3 being equal to 0. For our first example, 4x squared y over 7 times 21y over 20x cubed. The first thing we can do is cross-reduce the coefficients. The 4 and the 20 can be reduced to a 1 and a 5. The 21 and 7 can be reduced to a 3 and a 1. We then have the x squared and x cubed. The x squared on the numerator can be cancelled out with 2 of the x's on the denominator. This gives then a result of 3y squared over 5x. As far as non-permissible values, the only non-permissible value here is x cannot equal 0. For example B, first we cancel out the 8 and the 2 to a 4 and a 1. The s plus 5 on the denominator of the first rational expression cancels out with the s plus 5 on the numerator of the second. Note also that the s on the denominator of the first expression cancels with the s on the numerator of the second. This then gives a result of 20t times s minus 3 over s plus 3. For the non-permissible values, we look at the expressions before any cancelling was done. This means that s cannot equal negative 5 corresponding to the s plus 5, negative 3 corresponding to the s plus 3, and 0 corresponding to the s on the denominator. For example, C. First thing we have to do here, which we didn't have to do for the first examples, is do some factoring. The x squared minus 3x plus 2 factors to x minus 1 times x minus 2. The denominator for the first expression remains as 2x plus 3. The numerator of the second expression, it's a difference of squares, so we get 2x plus 3 times 2x minus 3. And the denominator of the second expression, we can factor out a negative 2. The reason I'm factoring out a negative 2 and not just a 2 is then I have the x minus 2 on the denominator, and note the x minus 2 on the numerator of the first expression. We can then do some canceling out. We've got the 2x plus 3's can cancel, and we've got the x minus 2's canceling. This gives a result of negative x minus 1 times 2x minus 3 over 2, and non-permissible values of negative 3 over 2 corresponding to the 2x plus 3 being equal to 0, and x cannot equal 2, that corresponds to x minus 2 being equal to 0.